So we'll be starting with we have a little bit done the D and F block. So we'll quickly just give a recap and we'll go forward. D and F block, okay. D and F block. So in D and F block, we have already studied that D block you see in the periodic table to dekha pale, like you can see that the periodic table has a part which is exactly in the middle of S and P block. ठीक है? D block का जो part है वो exactly S and P block के बीच में रहता है, right? So D block's part is exactly in the middle of S as well as P block. So this part is the D block. ठीक है? So D block में कौन से elements आते हैं? It is from which element, which group? So D block, the elements comes from D block में group number 3 से लेके group number 12 तक. Okay, the elements are from group number 3 to group number 12. Okay, so this D block elements are also known as, I'm just giving a recap and also we'll try to move forward, are also known as transition element. ठीक है? So D block elements are also known as transition element. Clear? Transition, the word transition means the qualification to become transition element is it should have partially filled. It should have partially filled D orbital. Mane 1 to 9 hopalai configuration. Okay. Transition elements are those elements which should have partially filled D subshell. ठीक है ऐसे? So it is having partially filled D subshell. Now in which state? Either in neutral or oxidized state, either in neutral or oxidized state. ठीक है? Either neutral state or oxidized state or तुम्हार it should have partially filled d orbitals. This is if it has d10 only. If d10 configuration to the khali, then it is not a transition element. If it has d10 completely, it is not a transition element. Examples are zinc, cadmium, as well as mercury. So zinc, cadmium, mercury they are not known as transition element. Kyun? Because zinc, cadmium, mercury, anti-oxidation state like zinc 2+, cadmium or 2+, mercury 2+. Are you other multiple oxidation state? Okay. Now what happens if it is zinc 2+? Let us see. Zinc or okay. Zinc or atomic number kiman? Let us see. Okay. I hope you have understood this part. Let us see. What is the atomic number of zinc? Zinc or atomic number whole 30. 30 wale ki hobo? Argon 4s2 3d10. This is the electronic configuration of zinc. Correct. এতিয়া জিংকৰ এইটো ইলেক্ট্ৰনিক কনফিগাৰেশ্যন আমাৰ 4s to 3d10 এতিয়া 3d10 to চাই থাকিব হা if it is zinc 2 plus zinc or oxidation number I equal 2 plus then it will become argon 3d10 electrons always go out from the higher shell okay electrons are always released from the higher shell it মই লিখি দি আছো electrons are always released from the higher subshell. Okay? Electrons are always released from the higher subshell. So if you are making zinc lose the electron, zinc or plus zinc 2 plus whole, no? If you're making this zinc lose the electron, then the electron actually goes out from 4s and not from 3d. Okay, so do not be confused. So this is the neutral state. A2 whole to my neutral state. Okay, and this zinc 2 plus is the oxidized state. Okay, so either in a neutral state or oxidized state, what happens if suppose zinc or electrons will like lose coherence, still it is maintaining its 3d10. So that's why zinc is not a transition element. Along with zinc, which other elements are not transition element? These three elements. Along with zinc, cadmium, and mercury are not to be considered as transition element. Okay. So these are the basic things we have discussed. Now, yes, at least we should remember few things about the D block. Okay, I'll just write. For example, D block starts from which period? D block starts from 4th period. Okay, it starts from 4th period. The elements in D block, the first, that will be sufficient. I'll just tell you a few of them. So group 2 ki ase, group 3 ki ase, group 4 ki ase. Okay. So group 2 ki ase. So elements in group 2. What are the elements in group 2? Scandium. Eto mon rahiba. Science teacher. Very cruel. Okay. Scandium, titanium, vanadium, chromium, then feconizen, then it is Fe, Co, Ni, Cu. Okay. Oh, this I just made a mistake. It is manganese. Sorry, I have written. Okay, I just write it again. It starts from group 3 to 12, not 2 to 12. Okay, 3 to 12. So I'll just write it again. Group 3, group 4, group 5, group 6, group 7, group 8, group 9, 10, 11, 12. Okay. So what are the elements? Science, teacher, very cruel, man, feconi, cu, zen. Okay. At least the first series you must remember. The first series, okay. Scandium to zinc. The first series you must remember. Okay. So what is the first series? Scandium to zinc. This is the first elemental series. So after that, scandium or pisot kiya hai. Next is scandium, right? Then it comes yttrium. Then it comes lanthanum. And then it comes actinum. ठीक है, so গোটেইখিনি মনত ৰাখাৰ দৰকাৰ নাই, just first two if you remember that will be sufficient. Zirconium, hafnium, Rutherfordium. Okay, then at last you can remember this particular group number 11, also known as the coinage elements: copper, silver, gold, at least this much, then zinc, cadmium, and mercury, you can remember. Okay, so this will be sufficient for us right now. Okay, so remember one thing, scandium up to zinc. Okay, this is known as the first transition series. Kiki, scandium to zinc. Okay, this is the first transition series, also known as 3D series. 3D series or first transition series. Then comes 4D series or second transition series. It comes from yttrium to cadmium, right? Second transition series is yttrium to cadmium. Okay, sir. It starts at yttrium, zirconium, and it ends at cadmium, CD. Clear? Fine. Then lanthanum to mercury. So like that, it is known as 5D series. Third transition series, that is from lanthanum to mercury. Okay, so similarly there is the 6D series or the fourth transition series. Like that, we have 4 different series in the D block elements. 4 different series in the D block elements. Hopefully you can understand. So the next thing, so we have understood what are transition elements. Why they are called as transition elements? Because these two are actually S block, and from 13 to 18 is the P block. Here to P block. So D block to exactly S block or P block or মাজত থাকে. Okay? So that is the reason. It is known as transition elements. Next, we discussed about special configuration like chromium, atomic number is 24, electronic configuration is argon, 4s2 3d 4 hobo lage, right? But as we know that this is the wrong configuration, this is not the correct configuration. Then what is the correct configuration? Chromium or a correct configuration to ki hobo argon 4s1 aru 3d 5 thakibo lagibo. Okay, argon 4s1 3d5. So this is the best configuration. Why this is correct and this is wrong? Okay, the reason is that D subshell has 5 orbitals. D subshell has 5 orbitals. What are the 5 orbitals? dxy, dyz, okay, dzx, dx square minus y square, and dz square. I need not tell you, you know that. Okay, these are the 5 d orbitals. Okay, in the D subshell, these are the 5 d orbitals. You can understand that. Now, a gote keta pasta orbital moi box method dot likhibo parim. I can write in the box method. So eta shellor bhitorot eta electron, eta orbitalor bhitorot eta electron ase. So there is 5 electrons, 1 electron in each orbital. Acha eta thakar karone ki hoy, repulsion among each orbitals becomes repulsion among each electrons in orbitals. Each orbital becomes equipoised. Equipoised means ki balanced ho thake. Okay, so the first thing is balanced repulsion between the electrons, balanced repulsion between the electrons of the subshell. This is the first point. I hope you can understand this. Second to ki hobo. What will be the second point? D subshell has 5 orbitals. Gotekini hole. Balanced repulsion between the electrons of D subshell. The second is very important, and that is higher exchange energy. Higher exchange energy. Higher exchange energy mane ki? Suppose these are 2 different orbitals. So the electrons in each orbital, they can exchange itself. Okay. For example, this is one electron in the first orbital, second electron in the second orbital. The electrons can, suppose this is the electron, this I'm representing by this pen, and this is the electron I'm representing by this pen. So they can exchange itself. They can change their position. Okay. So this is known as exchange. Or ever exchange hole ki hoy? Energy known as exchange energy molecule by atom bahirot ulay. Okay. The energy is released when this exchange is done. Tumi jodi analyze kora, and if a compound or a substance or an element releases energy jodi release kore diye, compound, element or substance becomes more and more stable. Energy kom thakile stability badhe. Okay, low energy is directly proportional to stability. Okay, higher exchange energy. So higher the number of exchanges. Okay, higher the number of exchanges. Higher will be the exchange energy. Okay, more stable will be the element, more stable will be the configuration. More stable will be the configuration. Okay, so Jiman exchanges over, higher the number of exchanges, higher will be the exchange energy, more stable will be the configuration. Very, very important. Okay? So, number of exchanges suppose how many electrons are there? Unpaired, 5. So each electron can jump to the other orbitals and can exchange itself. Okay. Pasta orbital ase. So how many electrons are there? 1, 2, 3, 4, 5. There are 5 electrons in each orbital, 1 in each orbital. The electrons what they can do is they can jump. Okay. They can jump and exchange their position. So they can jump and exchange their positions. Okay, they can jump and exchange their position. Electron will like neither mazot exchange kori. Second electron has already exchanged with the first electron, so the second can exchange itself with the third electron. The second Okay, so क्या देखा हम लोगों ने, like the second electron has exchanged its position with the other electrons. It has also exchanged with the first electron also. It is shown in by this particular curve. Okay. Similarly, third electron to teneka নিজৰ next electron লগত তাৰপিছত next electron লগত exchange কৰিব পাৰিব. So এনেকা চাব গলে the total number of exchanges is directly proportional to the exchange energy. Okay. Total number of exchanges is directly proportional to the exchange energy. Okay, so যিমান number of exchanges হৈ থাকিব electrons বিলাক মানে নিজৰ ঘৰ এৰি বেলেগৰ ঘৰত থাকা, so like that if it does, then it releases lot of exchange energy. যিমান exchange energy বাঢ়িব ইমান বেছি compound to stable হৈ থাকিব বা element to stable হৈ থাকিব with that particular configuration. So তাৰ কাৰণে chromium is more comfortable with 4 than 4s2 3d4 because it has got higher number of exchanges. Okay, so to find out the total number of exchanges, there is a formula. June jane ihote use koribo pare, june na jane dorkar nai. Okay, so number of possible exchanges is equal to total number of unpaired electrons. What is the total number of unpaired electrons? Total number of unpaired electrons is n. Okay, it is 5 over here. Total number of unpaired electron is 5 over here, and then followed by C. C is what? C is combination. Okay, C mane hol combination, and 2 permutation combination. Okay, 5C2 because 2 at a time exchange. Right? So how do we write that? I mean, it can likhim 5 into 4 into 3 into 2 into 1. ঠিক আছে, তলত কি থাকিব? তলত থাকিব 2 multiplied by 1. Okay, 2 multiplied by 1 মানে নিজৰ এই নাম্বাৰৰ নিজৰ তলৰ নাম্বাৰ কেইটাৰ লগত মাল্টিপ্লাই কৰি দিবা, that's all, into ওপৰত নিউমাৰেটৰটো এটো হ'ব, ডিনোমিনেটৰটো এটো হ'ব, আৰু এটা ফেক্টৰ হ'ব, that is 5 minus 2 factorial. Okay, 5 minus 2 factorial মানে কি? 3 factorial. 3 factorial মানে 3 ৰ পৰা তলৰ নাম্বাৰ কেইটাৰ লগত মাল্টিপ্লাই কৰিব লাগে. Okay, so it will be 5 into 4 into 3 into 2 into 1. 2 into 1. 5 minus 2 over 3. 3 factorial money 3 into 2 into 1. Okay, cancelled. 2 2 4. So it took you over 5 2 times is 10. Total number of possible exchanges is 10. Total number of possible exchanges is 10. ठीक है? ठीक है? Total number of possible exchanges is 10. Okay, so 10 hole tumi swa eta jodi 4 so if you write it 4 so to do the same calculation 4 into 3 into 2 into 1 তলত কি হ'ব 2 into 1 তাৰপিছত 4 minus 2 factorial 4 minus 2 factorial, so কি হ'ব 4 into 3 into 2 into 1 2 into 1 4 minus 2 is 2 only, so 2 into 1 etu calculation to কৰিলে তোমাৰ ultimately you will get 2 times of 3, that is 6. So number of possible exchanges if there is 4 unpaired electron is 6, and if there is 10 unpaired electron is 10. 5 unpaired electron is 10. So if we have 5 number of unpaired electrons, it has got more number of possible exchanges. Okay, higher the number of possible exchanges, more will be the exchange energy. Jiman exchange energy বাঢ়িব, jiman exchange energy বাঢ়িব, ইমান তোমাৰ like compound to basic বা element to basic stable hobo. Okay, so with that particular configuration the element will become more stable. So I'll write the summary right now. Okay, higher the number of higher the number of possible exchanges, higher the number of possible exchanges, higher will be the higher the number of possible exchanges. What will happen? Higher the number of possible exchanges, higher will be the exchange energy. Higher the exchange energy, higher will be the stability. ठीक है? Higher the number of possible exchanges, higher will be the exchange energy. Higher than exchange energy, higher will be the stability. This is the important part. So electronic configuration not enable kyo thake. So this part is there. Okay. There is a question. Is copper a transition element? ठीक है? Copper transition element होय ने no है. Okay. So they are asking directly that is copper a transition element? Yes or no? Simple. So to know that, you must see what are the oxidation number of copper. Acha, moi kene gompam car kiman oxidation number ase? It fixed. I'll give you the oxidation number of all elements. So let us write the oxidation number of all particular elements. Okay. By knowing the oxidation number of all particular elements, then it will not be any problem in knowing who has what oxidation number. Okay. All right. So the elements are scandium, vanadium, science teacher, no? Scandium, titanium, vanadium, chromium, manganese, then iron, cobalt, nickel, copper, and zinc. These are the elements. Okay. These are the elements in the periodic table, in the third 3D series of the periodic table. Okay. So here oxidation number to kike thake, they are all fixed. So it is +3, +2, +3, +4, vanadium whole +2, +3, +4, +5, chromium is +2, +3, +4, +5, +6, manganese over +2, +3, +4, +5, +6, +7. ठीक है? Iron over +2, +3, +4, +6. Cobalt is +2, +3. Okay. Nickel is also +2, +3. Copper is +1 or +2. Whereas zinc is only +2. Okay. So like that, you can understand that there are different oxidation number or a to fix thakibo. Try to remember like a 4. If I show you how a 4 looks like, the shape actually looks like a 4. Okay. So just try to remember the shape of these oxidation numbers for 3D series. And 3D series, 4D series, 5D series, all are having almost the same oxidation numbers. Okay. Hopefully you can understand this part. Is it clear? So how to know the oxidation number? So for every element, you can actually determine its oxidation number without any problem. Okay. Okay. So we have understood that there are various oxidation numbers. So let us, what we were saying, that part let us see. Is copper a transition element? Copper is a transition element? Why not? Okay. How do I know? we have to check its oxidation numbers. So what are the oxidation number of copper? It is +1 and +2. Correct. Copper is +1 and +2. That's a plus for us. Okay. Copper is +1 and +2. So since copper is +1 and +2, so let us see how it will look like. Copper electronic configuration to ki hobo argon 4s1 3d 10. Correct. Copper also has this exception in the electronic configuration. Why D10? Because of completely filled orbitals are more stable. Okay, completely filled orbitals are more stable. Now you can see that if I write, suppose copper ki configuration as +1 and +2. So let me write plus. Ultimately ki hobo copper plus argon 4s 1 electron gusi jabo, then 3d will become 10. Correct. Copper plus ki hobo argon 3d 10. Correct. And after that, if you see copper 2 plus jodi swa ki hobo argon 4s1 electron gusi go 3d 10 electron jabo, so it will become 3d9. So ultimately you can see that this has become 3d9. 3d9 means partially filled d orbitals, right? What does this suggest? This suggests partially filled d orbitals. Partially filled d orbitals. Okay, so partially filled d orbital hole, you two transition elements hobo. Okay, so it will become transition elements anyway. Okay, transition element. Okay, so if it is having a partially filled d orbital, either in the neutral state, ami ate dekha paisu neutral state or partially filled d orbital hua nai. Even in the first oxidation state, it is not d partially filled d orbital, but in the second oxidation state +2, it is showing 3d9, which is a partially filled d orbital as well as it's a transition element. So copper, yes, the answer is yes, copper is a transition element. Okay, so answer will be yes, copper is a transition element. Why? Because of this particular reason, 3d9 in the second oxidation state. Copper 2 plus it shows 3d9. All right, fine. I think it is understandable. If you have any confusion, you may ask. All right. If no confusion, let us move ahead. Okay. So let us go for the next property, that is the atomic size. Okay. Atomic size, atom or size, মানে যে কোনো d block element or atomic size to যদি তুমি সোয়া, what is the atomic size? You can see that it varies on two factors. Okay, varies on two factors. So what are the two factors? Number one is nuclear charge. Nuclear charge. Nuclear charge basically means number of protons in the nucleus. Number of protons in nucleus. Okay. So atomic size to ki hobo ultimately? Atomic size is inversely proportional to nuclear charge. Okay. Atomic size is inversely proportional to nuclear charge. Number two, nuclear charge hoega. Next, number two is, what is number two? Atomic nuclear charge. Next is shielding power. Shielding power or factor. It is also known as screening factor. Okay, shielding keteba. It may be also known as screening factor. Okay. Okay, it is known as screening factor. 0%. What is a screening factor? Screening factor means something which shields. Okay, shields mane ki rokhai diya to. Okay, what is this? What is this thing? Okay, shielding power. So atomic size is directly proportional to the shielding power. Okay, atomic size to directly proportional to the shielding power. So keneke hoy bostu amar sabo lagibo. Okay, so there is two things. One, so you understood nuclear charge. Atomic size is inversely proportional to nuclear charge. Nuclear charge to bahile ki hoy atomic attraction to bahi jay electrons, outermost electrons are nucleus or majo. Okay, so nuclear charge, what it does is nuclear charge increases the attraction between nucleus and valence electrons. Valence মানে last or shell or যেটা electrons থাকে এটা valence electrons বুলি কয়. Valence electrons. Fine. The other part is the shielding power. Shielding power to কি হয়? Suppose, for example, there is a thing. First, let us know that. After that, shielding power to আমি ভালকে discuss করিম. Scandium, okay, atomic size to কেনেকে vary করে. Okay, atomic size, how do they vary? Scandium is greater than titanium, is greater than vanadium, is greater than chromium. Okay, is greater than manganese. Okay, তাৰপিছত manganese পিছত কি আছে? Manganese, iron, cobalt and nickel. So iron, cobalt and nickel is almost of the same size. Almost of the same size. And copper is smaller than zinc. Okay, so that means copper is actually smaller than zinc. Normally, আমি কি পঢ়ি আহিছো that from left to right, atomic size decreases in a periodic table. But left to right, you can see that I can write like this also. Okay, so copper to zinc, what happens? The size actually increases. Kyo increase hai? Because the shielding power actually increases. So in zinc has a higher shielding power than copper. Okay, what is the reason behind that? Zinc has higher shielding power compared to copper. ठीक है, zinc or shielding power to basic. Can it be basic? Let us see. Okay, suppose you can see, suppose in case of copper, the nucleus of copper is here. So what is the configuration of copper? 4s1 3d10. Okay, copper configuration to key argon 3d10. So how many electrons? So 3d is 4s is outside, 3d is inside, right? 3d to pisot likha jai because it has higher energy level, but normally 3d is outside and 4s is inside according to the shell numbers. So there are electrons in the 3d shell. Okay, so what are the electrons? 1 2 3 4 5 6 7 8 9 10 10টা इलेक्ट्रॉन আছে ठीक है फिर 4s1 how many electrons are there 1 okay so কি হয় ইহতৰ মাজত ৰিপালশন হয় অকমান there is repulsion among the electrons ठीक है so these electrons are among each other so there is repulsion among the electrons so this repulsion means এইটো electron victim electron বুলি ধৰি লোৱা আৰু গোটেই কেইটা ভিতৰৰ electrons কেইটা কি হয় ঠেলিব বিচাৰে মানে like it is pushing it outside this electron is being pushed outside by the electrons which are inside okay this pushing effect by the inner electrons towards the outermost electron is known as shielding effect now shielding effect takes place to an electron by the inner electron as well as from the electrons of the same shell কিন্তু তোমাৰ কপাৰৰ ক্ষেত্ৰত খালি এটা ইলেক্ট্ৰন আছে বাহিৰৰ পিনে ঠিক আছে so this is nothing but the shielding power of 3d electrons to the 4s electron আৰু যিমান বাহিৰৰ পিনে ঠেলিব যিমান shielding power টো ডাঙৰ হ'ব ইলেক্ট্ৰনটো বাহিৰৰ পিনে ওলাই যাব right the electrons will go farther from the nucleus to a2 electron to কি হ'ব it will become farther from the nucleus so যিমান দূৰ যাব atomic size to ultimately কি হ'ব বাঢ়িব now in the case of zinc what happens in the case of zinc what happens okay zinc electronic configuration is argon 4s2 3d 10 4s2 3d10 okay suppose so there is the 4s 3d then comes 4s so 3d কেটা electron আছে 10টা electron আছে there is 10 electrons 1 2 3 4 5 6 7 8 9 আৰু 10টা right in the 4s shell how many electrons are there there are 2 electrons 1 2 4s shell there is 2 electrons okay so this is our 3d10 and this is our 4s2 so you see that suppose this is the victim electrons this is the victim electron this one so a2 electron repulsion কৰ পৰা খাই আছে like it is getting repulsion from the inner electrons and this electron will be also repulsed by the outermost electron okay inner electron and this electron will be also repulsed from the outermost electron ठीक है are you getting the point so in etu bahirar electron etu electron কি কৰিছে inner electron to repulsion কৰি আছে আৰু bahirar electron to repulsion কৰি আছে okay ultimately what happens the shielding power here is higher compared to the shielding power in copper at least copper did not have enemy in the same house right it did not have an electron in the 4s shell which also pushed it outside here what happens one more extra electron has came so shielding power is greater in case of zinc than in copper therefore zinc or size to copper che dangor hobo lage because of the shielding power ठीक है normally ki hoy copper comes left zinc comes right so after copper zinc size should reduce according to the last theory but because of the increase in shielding power what happens the size increases okay so we have explained why copper is smaller than zinc question was why copper is smaller than zinc why copper is smaller than zinc copper is an element which is smaller than zinc that has been asked ठीक है copper to zinc or horu kya that is the question and we have answered that now the second question is why these three are equal why these three elements are equal okay why these three elements are equal size or reason to be So why iron, cobalt, and nickel is equal size? Because they have the same shielding power. Their shielding power to actually numerically ulai lobo paro. But for our course, for our syllabus, we need not find it. Amar dorkar nai. Okay, we did not find the uh, shielding power ulabo na lage. It on class 11 so I think most of you could do it in class 11. Now we do not need it anymore. So these three elements have the equal shielding power. Okay, this three has the equal shielding power. Has equal shielding power. ठीक है? All this has the equal shielding power. I hope you have understood this part. Okay. So zinc. So copper to zinc, the size increases, but from iron, cobalt, and nickel has equal shielding power. That's all. I hope you have understood. If you have any question, please ask. Okay. So if there is no question, let us move ahead. So our atomic size to finally conclusion ki ulale. This okay, we have not discussed why scandium, titanium, vanadium, chromium, manganese, why their size decreases. Size decreases because of increase in nuclear charge. Okay. A pasta element or size to kyo komi thake, like scandium to titanium. That is the normal reason. Left to right, the size decreases because of the increase in nuclear charge. Okay. This 5 actually, the size of this element decreases due to increase in nuclear charge. Due to increase in nuclear charge. Okay, due to increase in nuclear charge. All right. Okay, due to increase in nuclear charge. Is it over? Next. Transition elements or Kisuman property as let us discuss all these. Okay. So let us discuss about some of the properties of transition elements. So Kisuman property hold directly likhe upare that they have multiple oxidation state. Already we have seen Gotegator multiple oxidation state, each differs by only one unit. Okay? Multiple oxidation state all differs by single unit. Number one is multiple oxidation state. Okay. Number two is they are mostly colored in nature. Why they are colored in nature? Because they have unpaired electrons. Okay. Produces colored ions. Why? Because they have unpaired electrons. Unpaired electrons থাকার কারণে they are mostly colored. Okay. Number three is they form complexes. Already আমি পড়িয়েছিল coordination compound form complexes. Example is CONH3 whole 6 3 plus. ठीक है? This is the complex, one of the complex. Complex माने कि पानी dissolve नुहुआ वस्तु. Okay. Do not dissolve in water or do not dissolve in aqueous solution. Okay. पानी dissolve ना होए. Dissolve माने भांगी ना जाए. This does not break down. ठीक है? Number four, catalytic properties. It is most of the times you can see that D block elements black catalyst form correct. Catalytic properties থাকে. Okay. So what are these properties? Like some of the examples are nickel, palladium, platinum. Okay, then molybdenum oxide MO2O3, chromic oxide CrO3. So in aqueous of you can see that all D block elements or transition elements are in use, right? Then you can see silver also is used sometimes. Then what else? I can remember. Amalgamated to thake almost. Mercury use kora thaka. Then copper. Okay, copper and heat. You have seen many reactions, many organic chemistry reactions you have seen using this sort of catalysts. Correct? So ekhini catalyst thakar karone because they are mostly transition elements. And why they form catalytic properties? Again, because of possessing multiple oxidation state. Why they are good catalysts? Because they have multiple oxidation state. That's all. Since it has multiple oxidation state. Since it has multiple oxidation state. Okay. Since it has multiple oxidation state. Clear? All right. A question is just as a like explanation or reasoning question, it may appear. Question is zinc. Okay? Zinc is not a transition element. Zinc is not a transition element, but copper is. Okay, zinc is not a transition element, but copper is. So you can tell it very clearly. Zinc has only two oxidation states. Zinc has only one oxidation state, zinc 2 plus. Copper has two oxidation states, copper plus and copper 2 plus. Either in the neutral state or in the oxidized state, it must have partially filled d orbitals. Okay, partially filled d orbitals. So zinc do not have partially filled D subshell either in neutral or oxidized state. Don't have partially filled D subshell either in neutral or oxidized state. This is a very, very important point. It does not have any partially filled D subshell either in the neutral or oxidized state. But talking about copper, it has, right, copper 2 plus already আমি দেখিছো copper 2 plus configuration কি আছিলে argon 4s1 3d10 ठीक है. So since it is 4s1 3d10, okay, that's why it is having copper 2 plus. Argon is 4s1 3d10. So since it is 4s1 3d10, so that's why it is sorry, this copper 2 plus হলে কি হবে 4s1 নয় 3d9 হবে না 3d9 4s will not be there since it is having 3d9 configuration, which is a partially filled d orbital. 3d9 হলে কি হবে 3d9. Okay, copper 2 plus means 3d9, simply 3d9. So it has what partially filled d orbitals. Partially filled d subshell. Okay, partially filled d subshell. So hetu karone mane ki hoy copper is a transition element but zinc is not. Some of the properties, ketamine physical properties like silome. Some of the properties of transition elements. Which are the properties? Let us see.
Sir, can you rotate your phone?
ঠিক আছে. Is it all right now?
Yes, sir, it's fine.
So some of the physical properties that we can talk about. Physical properties. Okay. So what are some of the physical properties? So number one, high tensile strength. High tensile strength. Okay. We know that chain hog, Goller chain hog, wires, so they are made with D block elements or transition elements like copper and silver, gold. Okay. So tensile strength means you take a wire, try to pull. If it breaks, it has low tensile strength. And if it does not break, it has high tensile strength. Okay. So 10 high tensile strength. Number two, ductility. Already I mean like kisuman words compound. Ductility means the ability to be drawn into wires. Okay. Drawn into wires. Okay. Number three, malleability. What is this? Malleability. What is this malleability? It is the beaten into sheets, right? Beaten into sheets. Flat. Okay, it can be flattened. So that is the property of malleability. Then it has metallic luster. ठीक है, एटोर এটা metallic luster আছে. They are very good conductor of electricity and heat. Okay, so that also we may write, because we know that wires are created of this only. So good thermal and electrical properties. So these are some of the physical properties that we commonly discuss. Okay. Metallic cluster বিষয়ে এটা point আছে that zinc, cadmium, mercury and manganese do not have metallic cluster except metallic cluster না থাকে এটা zinc, cadmium, mercury, okay, manganese. So these elements do not have metallic luster. You might say, sir, but mercury is shiny. Yes, it is shiny. But luster meaning to be like luster hole. When a metal is freshly cut, then the exposed surface should be shiny. That is known as metallic luster. So we have come to know what are the different physical properties. What are the different, one more important thing is hardness that we have not discussed. Hardness. Okay, hardness. So most of the transition element is hard. Transition element is hard. Kyun hard hai? We'll discuss that also, due to the presence of unpaired electrons. Okay, due to the presence of unpaired electrons. Okay, so they are very, very hard. Normally metals bilak, there are different metals. The bonding between metals and metals is known as metallic bond, that we have already studied in the first chapter, solid state. So bonding to keneke hai? The bonding takes place with the help of free electrons between the metals. The bonding takes place with the help of free electrons between the metals. Okay, so if free electrons jiman thakibo iman besi heri amar bonding strong hoy. Okay, and the number of free electrons is actually dependent on the number of unpaired electrons. Number of unpaired electrons. So it depends directly on the number of unpaired electrons. Number of unpaired electrons. Okay. So this number of unpaired electrons jiman beshi thake, iman beshi strong bond thake. Okay. And due to higher metallic bond, what happens? Higher or stronger metallic bond, hardness is also very high. Transition element is hard due to the presence of unpaired electrons. Because the metallic bonding, the bonding jab create kora hoy, this is all done by the unpaired electrons. So higher the number of unpaired electrons, stronger will be the bonding, and this will directly affect two things. Okay, number of unpaired electrons, it directly affects this important factor known as melting point. Okay. It directly affects the melting point. Okay, melting point. Melting point becomes higher. Melting point becomes higher when the metallic bonding is very strong. Okay, melting point is directly proportional to number of unpaired electrons. Fine. Melting point to directly proportional to number of unpaired electrons. So that is very important. Fine, no? This is no problem. So number of unpaired electrons is directly proportional to the melting point is directly proportional to the number of unpaired electrons. Okay? So this is very, very important point. Okay, now saying so many things, let us review something. Just it is the screen is turning again and again. Okay, done. So we have discussed so many things. Now let us discuss one or two things more. The metals are bonding করে no, like when two metals, whether it is copper, whether it is zinc, whether it is any metal, when these metals actually form the bonding, then this bond is known as metallic bond. Okay, they are known as metallic bond. So metallic bond to ki hoy? Metallic bond. Okay, so metallic bond to ki hoy? This is bonding between metals and metals. How they are bonded? With their free electrons or with their unpaired electrons. So metallic bond to bhangi bole junto energy dorkar hoy, that is known as enthalpy of atomization. Enthalpy of atomization to break down metallic bonds. Okay, to break down metallic bonds. ठीक है? যেতিয়া মেটাল হৈ থাকে, একটা সলিড হৈ থাকে, suppose MS. ठीक है? MS মানে all the metals are linked to each other and they are forming a network of solid. They are forming a solid network. Okay, but when you apply enthalpy of atomization, it creates M gas. Okay, it directly creates metal gas. মানে eta atom ho jay, like this becomes one atom. All right, suppose if it is M2, then it becomes 2M. It breaks down that way. দুটা M আছে, M2 লিখিলো, এটো enthalpy of atomization দি দিলে এটো কি হ'ব? It will become 2M, which is a gas. Fine. So this is known as enthalpy of atomization to break down metallic bonds. Fine, no? Similarly, যদি আয়নিক বন্ডটো ভাঙিব লাগে হেতু ল্যাটিস এনার্জি বুলি কয়, আর যদি কোভ্যালেন্ট বন্ড ভাঙিব লাগে হেতু সিম্পলি বন্ড এনার্জি বুলি কয়, কিন্তু আমাৰ ইয়াতে দৰকাৰ নাই. So enthalpy of atomization is the energy required to break metals or metallic bond. In fact, okay, because they are so well bonded, so we can come to know that there is a famous element, tungsten. Okay, this is just for knowledge, huh? Tungsten, which is represented by W, has the highest melting point. Melting point to attack basic has the highest melting point. Tungsten has the highest melting point. Fine. Next is one more thing that is known as the, I have already discussed melting point. No, melting point we have already discussed. Now let us discuss the boiling point. Boiling point. boiling point. Boiling point to ki hobo? Boiling point see melting point to e jodi high thake then hole boiling point definitely it comes after the melting point, right? First comes melting point, solid to liquid. tar piche ahe boiling point when you convert from liquid to solid. So boiling point to generally high thake. Okay, boiling point it is generally high. ठीक है, melting boiling point it is generally high. Therefore, what is the volatility? Therefore, it has lower volatility. Volatility कम था, it has lower volatility. Fine, it has lower volatility. Volatility means tendency to form vapors. Tendency to form vapors. Okay. Volatility means tendency to form vapors. Tendency to form vapors. ठीक है? Therefore, it has lower volatility, which is the tendency to form vapors. Fine. So we have discussed about the different varieties, which is the physical properties as well as the some of the like common properties of transition elements. So I hope this part is all right. So let's see what we have discussed. We have discussed all the like physical properties, transition elements. We have discussed the various oxidation states. Okay. Now let us discuss something more about the oxidation state. Which are the some of the common stable oxidation state? So what's a stable kuntu hai? Okay. So +3 is very stable. +4 is next stable. +5 for vanadium, +5 is very stable. Chromium +6 is very stable. Manganese +7 is very stable. Okay. Other than this, there are other oxidation states also, which we'll discuss. Then for iron, +3 is very stable. Cobalt, +3 is very stable. Nickel, +2 is very stable. Copper, +2 is very stable. And zinc, +2 is very stable. Okay. Other than this, chromium, +3 is very stable. Manganese, +2 is very stable. Okay. So these are some of the most stable oxidation states. Okay. All right. So what we'll do is we'll end here. Tomorrow we'll discuss something more about it. So tomorrow also we'll do one online class. I'll take the class after your physics class and everything will be over. Okay. So tomorrow we'll do the class in the late evening online. We'll continue with the DNF block. All right. So thank you. I'll just upload the class today. Thank you, everyone.